Okay, let's go back to before I was so rudely interrupted. So if we're looking at numbers that are smaller than -2 and larger than +2 at the same time, they do not exist. Less than -2 is over here, greater than 2 is over here. Those don't overlap. You cannot have those at the same time. So since there is no overlap, this is going to be a no solutions. Okay, then we're going to take a look at the next one. So we take off the absolute value. It doesn't matter that you have the equals to sign or not, except for when you're graphing. It's just a matter of whether you fill in the point or not. So we're going to have x is greater than or equal to -2. Remember, greater, so if this is a greater than sign to start with, you're going to have an or in there. And then x is less than or equal to -2.
What do you think about positive?
Oh yeah, +2. Thank you. So on the ors, we're pretty much okay going ahead and making a graph. I'm just going to think about what this looks like. So if I'm greater than or equal to -2, that would start here and go to the right. If I'm less than +2, I'd start here and go to the left. If it's an or, it's basically it's on this one or on this one, and you keep everything, you're going to get the whole number line as your solution. And that's because an absolute value, if you think about it, it's always positive. It doesn't matter what x is. A positive number is always bigger than a negative number. And so this is all real numbers. And if you want to do that double bar R thing, you can. Double bar R. Okay. So those are our special cases. So when you see negatives, this only happens when you have the absolute value isolated, just like yesterday. So an absolute value is positive. It's never going to be less than a negative. So in theory, you could use a little bit of logic and avoid doing any of the graphs or even breaking this apart. This is positive, which is not going to be less than a negative ever. And so that's where no solutions comes from. But this would be positive, and it's always bigger than a negative, and so that's where you could get all real numbers. So if that helps you, you could actually eliminate all of this down here. But I showed this to you because if you don't think about that and you just go through the whole thing, you can still get the no solutions and the all real numbers just using your inequality stuff. Okay, so let's go on to number 5. So we're going to have a little bit more involved with the solving on these. So this is, the absolute value is isolated, so I can go ahead and figure things out. This is less than, which tells me this is going to be an and problem. And what we do is we just take the absolute value off for the first one. I just have x minus 5 is less than 3. And then we have and the part that's in the absolute value you can leave the same. It's still x minus 5. We're not changing the left part. It's everything after that that we change. So the less than changes to greater than, and 3 changes to -3. Okay, so it's kind of like the equation. We go from +3 to -3, but we have to flip the sign because we changed that from positive to negative. And then we solve it. So add 5, x is less than 8. And over here we add 5, x is greater than 2. So if you don't want to do that thing where you combine them, you could just put 8 on here and 2 and think about it. Okay, can I have numbers that are less than 8 and bigger than 2? Did you guys like doing the overlap thing where you graphed them and found where they overlapped? So you could do that just kind of down here. I could, okay, 8 less than 8 would be like this. Greater than 2 would be like this, and you figure out where they overlap would be between 2 and 8. So on your final answer, we could do this. Or you could do one of those things where you combine the inequalities together, but sometimes that just makes it more complicated. So those are the numbers, and so if you think about it, you could try a number in there. Okay, 5's in there somewhere. Is 5 less than 8 and bigger than 2? Yes, it is. So you can also test that to make sure you're kind of in the right part of the graph. All right, cool beans. That one's good. Everybody done with it? All right, let's look at number 6. So my absolute value is already isolated. I don't have to solve for it. We can go ahead and just separate this apart. Since this is greater than, we can go ahead and go, okay, no, this is going to be an or. So we break this apart. 2x minus 3 is greater than or equal to 9. On the first one, you just take off the absolute value. Everything else stays the same. Then we have the or. On the second equation, the left side stays the same, 2x minus 3, but we flip this, so we're going to get less than or equal to, and we change 9 to negative 9. So it's on the second one that you flip the symbol and change the sign. Okay, so we've got to solve both of those before we can graph. So I'm going to add 3 on that first one. We'll get 2x is greater than or equal to 12. Then divide by 2. We get x is greater than or equal to 6. So that's the first half of my answer. Then I can come over here and you basically do the same steps. Add 3, except we're adding it to negative 9, which gives me negative 6 on the right side. And we'll have 2x is less than or equal to negative 6. Divide by 2, divide by 2. X is less than or equal to negative 3. And then we have an or in between here. So there's my solution. And then I can figure out the graph. So on the ors, pretty much you're just going to have 2 pieces. So if I put negative 3 down here, would I fill in the dot on these or not? Mm-hmm. Yes. Why? Because we have this equal to line here and here. I do fill in the dots. So at negative 3, I'm going to fill it in. Go to the left. It's less than negative 3. And then if I put 6 over here, it would fill in. You guys are going to have number lines on your papers already. I'm just making simple ones so we can get through this relatively quickly. And so it's either less than negative 3 or equal to negative 3, or it's greater than or equal to 6. And on those ors, usually you get those 2 pieces, unless they end up overlapping, and that's when you end up with all real numbers. But usually you just have those 2 pieces like that. Okay, 2 more. We're going to crank it up a little bit with the solving. So you have to isolate the absolute values first. Okay? So if there's anything on the outside of the absolute value on the left-hand side, we've got to get rid of it. So I have this 2. I have the minus 6. I can't divide by 2 yet. Yeah, we want to add 6 first. Just like solving a normal equation, you undo the addition and subtraction first. Good job. So this is going to be less than or equal to 16. Over here we have 2 absolute value of x minus 4. Okay, then we can get rid of the 2. Remember, you cannot distribute with absolute value. It's just a thing that sometimes it works and sometimes it doesn't, so we just try not to do it. So instead, we're going to divide by 2 and divide by 2. And we get the absolute value of x minus 4 as less than or equal to 8. This, now that we've done that, that's when we can actually branch out and do our 2 equations, inequalities actually. So I'd have x minus 4 is less than or equal to 8. Oh, and I forgot to ask if it's and or. So it's less than, so it would be and. Less than if you're using my mnemonic device. So I'm going to have an and. And then we do the second one. X minus 4 is greater than or equal to negative 8. So we flipped it from less than to greater than, changed it from 8 to negative 8. And those are not going to be too bad to solve because what do? Just add 4. Good. So add 4 to both sides. And I'm just going to go down here on the notebook paper. So I'm going to get x is less than or equal to 12. And then over here, if I add 4, I'm going to get x is greater than or equal to negative 4. Like that. So that's my solution, we think. I don't remember. Yeah, I think that works. So if we make a little number line and just put our important numbers on it to save some time. Negative 4 is there, 12 is there. So if we think about it, less than or equal to 12 would be from 12 to the left.
So we can't see it.
I'm sorry, here you go. You're right, I did go off the screen. So I made a little number line with just -4 and 12. So x is less than or equal to 12 would be a point at 12 going to the left. Greater than or equal to -4 would be from -4 to the right. And if it's an and, we're looking for where they overlap. And you want to make sure that they overlap. And they do. They overlap between -4 and 12. So that's where we're going to find all the numbers that are less than or equal to 12 and greater than or equal to -4 would be in here. And you could try a test number. You could try, say, 3. We could say, okay, 3 is about right here. Say, okay, if I put 3 in here, is that less than or equal to 12? Yes. I give it 3 over here. Is that greater than or equal to -4? Yes. And so it works. You could check it that way. And since we had the equal to bars, don't forget to fill in points. So this is my actual graph. This down here is just me scribbling to figure it out. So I'll get rid of that and just leave you with the answer. Okay. Una más. One more. I don't know why I keep looking at notes that aren't the same. All right. So on number 8, first we have to isolate the absolute value. Just going to write that on there again. So how do I get rid of this -2? Divide. Now, with inequalities, when I divide by a negative, something special happens. So this less than becomes a greater than or equal to. So it's important that you haven't figured out the less than, greater, less than, whether it's an and or an or, until you get this by itself. Because now this is flipped around. When you divide by a negative, you put flip, everything is going to flip there. And so now it's greater than, greater, and so that's going to be an or. Does that make sense? Okay. So now we have x plus 3 is greater than or equal to -5, or x plus 3, and this is where we flip it back, less than or equal to, and then we change it to +5. Does anybody notice that this was negative to start with?
Yeah, does that mean it's...
So before I do a whole lot more work, I could probably think about this. Okay, so what's in the absolute value is always positive. Is that going to always be greater than a negative? Yeah, positive is always bigger than negative.
But yes. No.
So I would warn, I guess, that this is going to be all real numbers. I'll go ahead and work it out just so you can see, because I think a lot of people just like to go through the whole process no matter what, and that part confuses them. So if I go ahead and solve this, I subtract 3 here, I'll get x is greater than or equal to -2, or solve this one, we subtract 3, x is less than or equal to 2.
Wouldn't that make it -8?
Yep, -8. What? I can't subtract. Thank you, Sophie. It's the second time you saved me today. Alright, so I do a number line. I put -8 down here. I'm going to put 2 over here. And we're going to look at the two graphs separately. So greater than or equal to -8. Start over here, would go to the right. Less than or equal to 2 would start here and go to the left. Now usually we have 2 rays that don't cross, but these cross. And when this happens, it can be any number on this one or on this one, which basically covers all numbers in existence. So that means that it is all real numbers. The entire number line you could, in theory, color in, and it would be all real numbers, or you could do that double bar R thing. Okay, that's it.